Okay, I think we'll get started. So for today's lab, we're going to use the UART protocol, Universal Asynchronous Receive and Transmit, to write an ASCII character to the computer. We'll be just using Putty to view this. This is on Windows, but would work on Unix as well. Another chance to learn a little bit about bit banging. So bit banging is when you use the software itself to write individual bits out through the UART line. And we'll again be looking at the ASCII table. The UART protocol starts with holds the voltage high and is active low. So it goes low to send. The first bit it sends is a start bit. This tells the receiver that it's about to send some data. Then it sends 8 bits of data, which can encompass the ASCII characters. And then it sends a stop bit. And then it goes back to just holding high, waiting to transmit the next bit. Again, good to print yourself out a copy of the ASCII characters, and you can find that readily online. The general structure of the ASCII characters is that when we're talking about the letters of the alphabet, the first 3 letters here, or first 3 numbers here, 0, 1, 0 and 0, 1, 1, distinguish between uppercase and lowercase. So this is the flag for whether we're upper or lower. And then the remaining 5 bits pick out the code for the letter. And whether it's uppercase or lowercase, these are the same. So if you choose a T, capital T, and a lowercase t, these will be the same. Numbers are of this form. And if you watched the video on receiving data, I think I had a mistake here. So it's 0011. I think I had 10110, which would just be a lowercase letter. So 0011, and then the remaining 4 bits are the binary values. All right, let's go to the device. What we're going to do here is just we're gonna just type in a binary for a particular ASCII character, and then we'll open up Putty, and when we press a button, it'll send that character. All right, so here we are with the program, and program to write to the computer via UART. I have just experimentally determined that a good baud rate for this is 3,550, and so you have to match the baud rate with your send and receive. So that's, I guess, a disadvantage of the UART procedure. Your 2 devices that are talking to each other have to match their baud rate. This is not a typical baud rate, but it's one that works for the delays that I'm using here. This stuff here is all the initial things we need to have to get things set up in terms of the configuration bits and the include file. This here sets the program counter to start at main, and then we go to main. We need to set inputs and outputs. So in this case, we're going to be using GP1 as an input for our button press, and then GP0 as an output. So by putting a 0 here, that makes GP0 0, and a 1 here makes GP1. Makes GP0 an output, and putting a 1 here makes GP1 an input. The remaining 2 don't matter. We're not using that here. Tris6 writes that to the Tris so that the PIC10F200 is ready to go in terms of its inputs and outputs. This bit we could ignore. We could cut this out. This is just making sure that GP2 acts as an input rather than an external clock. We go into the main loop of the program now, and we start by setting the output high. And you can see on the circuit here, that's I'm indicating I've got an LED circuit coming off of the output, and so it's holding high at 5 volts, which is the resting state for UART. Then we jump into this polling part here. These two lines are polling GP1 to see if we press the button or not. If we press the button, we're going to move the literal 8 into memory. This is for the right loop, as a counter for the right loop. So we're going to store this in memory, and then we're going to call bit by bit, we're going to just decrement this down as we call bit by bit. And then when we reach 8 bits, then we'll kick it out to, we're nowhere at the end of our data send. Here is the ASCII character we're going to send, our data to send. ASCII or otherwise. So this is the ASCII. This is the binary for the ASCII character small a. We're going to write that to the memory, and we'll put this in position 17, memory register 17. And now we're good to go. We're going to send this now out to the computer. So we'll have start bit, and so this little piece clears, so it sets low GP0, and we do this for a delay of 4. This is what matches, so this matches the baud rate. If you had this as a different delay, then you'd have to get a different baud rate. Now we're going to go into the right loop, and so we've sent the start bit. Now we're going to read the 0 bit from 17, and this set here, we've seen this a couple of times now as a strategy to read either a 1 or a 0 and push that to an output. So if it's set, we're going to skip this, and we'll be here. This is asking if it's clear. Well, it isn't. It's set, so that means we're going to set GP0, so that's high, and then we're going to clear GP0, that's low, and so that will send the individual bit 0. Then we're going to rotate right through the register, and this rotates 17, and the 1 here says it rewrites it then back in 17 rather than the working register. If you put a 0 here, it would go into the working register. Then we move 4 to the working register and use that as a delay. So this again matches the baud rate. And we're decrementing our counter here now. The counter was 8, and so that's going to run through all 8 of these data bits. That's stored in 17. Then we have to write a stop bit. And so the stop bit part is just send a clear to write a stop bit. Again, the delay for matching the baud rate. And then we go back to setting ourself up. I put just a little delay here. It isn't really necessary because it goes back and waits for us to push a button. But if we were to hold the button down, then this would go, every maybe half second or so. All right, so let me first make sure this builds, and then we'll write this to the PIC. So we're good and ready to go. So now I will open up Putty, and for my computer, the UART device, this UART device is on COM4, and again we have to set the right baud rate, and we'll open that now, and we'll move this, make sure that you can see it. Okay, so here is Putty open, and right now the PIC10F200 is just polling, waiting for a button push. So we will now, I've got the button right here, so we'll make a button push, and we get the ASCII character A as we intended to send. All right, well, let's make that a capital A. So if we want a capital A, we would just change this to a 0, and that should be a capital A. Now I'm going to shrink the window here, and hopefully we can still see around my other cameras. Putty here. Now when I build this, let's see. Yeah, when I build this, we're going to get a little spurious action at the beginning, and we'll get nonsense kicked out. So if you see here on Putty, we get just some randomness coming out. But now we're set. So that could be an issue if you're writing a program. You'll want to make sure that the PIC is up and running before you pull it to get information. But now we click the button and we're getting a capital A. Right? And so this is of limited use because you have to reflash the chip every time you want to change the ASCII character. But you can think about, if you did watch the other video on reading and storing, you could think about how you could read and store and then maybe do something with that. Change the capital to a lowercase or something like that. So you send a capital A and then it'll send you back a lowercase a. Those would be nice projects to combine both of these together. We're going to actually be looking at a case where we do something like that, but we're going to also include another shift register and look at integrating other integrated circuits, ICs, with the PIC10F200 to give us some more versatility. All right, so I think that does it for this video, and hopefully you can practice with this and feel comfortable both reading and writing now to the computer via the UART protocol.